Okay, so here the question is, what is the additive inverse of negative 4a, and what is the multiplicative inverse of negative 4a, and how do you know you're right? Well, the additive inverse of negative 4a, just different color there, is just positive 4a. Additive inverses, right, are opposites of each other through addition. In other words, when you add them, you get 0. Now this will give you 0 if you think about what's happening, because this right here, negative 4a, it's really just negative 4 times a. And if you think about what that means, it's like having 4 negative groups of a. So negative a plus negative a plus, right, negative a plus negative a. 4 negative groups of a. And here, what do we have? Well, we have the opposite. We have 4 positive groups of a plus a plus a plus a. And if you're stuck as to why that's true, think about numerical examples. If I said 4 times 3 versus 4 times, or negative 4 times 3, well here, you might think, oh, it's negative 4 times 3. You can switch that negative sign around, just kind of pull it out there, negative 1 times 4 times 3. Use commutative property, and we get 4 times negative 1 times 3. Oops, that's a 3. And then we have this, 4 times negative 3. Now, we'll come back to that in a second. I just rearranged it, right? Again, this was negative 4. I pulled it apart into negative 1 times 4. And then I rearranged it. I moved the negative 1 over here. So I can rewrite it like this, right? Just step by step. And you'll see why that's useful in a second to help envision this problem. So 4 times 3, that's just 12. But you can think of that as 4 groups of 3. And that is exactly what we're saying here, 4 groups of A. 4 groups of 3, 3 could be A or whatever. Here, we have 4 groups of negative 3. So we can, in the same way, we can think of that as negative 3 plus negative 3 plus negative 3 plus negative 3. Or negative A plus negative A plus negative A plus negative A. Now, yes, it's true. Negative 3, right, could also represent negative A. Or, think algebraically, it could have just been 3. Plugging it in, we would get negative 3. So if you think about that discrepancy there, I understand. If you're not thinking about it, disregard what I'm saying. All I'm trying to show you here is that negative A and negative A and negative A and negative A is like 4 times negative 3. These things are similar. Where am I going with this? Well, I rambled quite a bit there. However, what you can see now is that we have 4 opposites, right? Going back to this example, 3 and negative 3 is 0. And that happens 4 times. In other words, these all cancel each other out. The same thing is true here, right? All of this stuff cancels out to this number right here, 0. So that is the additive inverse. When you add them, you get 0. This often is referred to as opposites, right? These are opposites of each other. Now the multiplicative inverse follows a similar idea. I mean, any number times its reciprocal will give you 1. That shows you the multiplicative inverse of a number. So what is the reciprocal of negative 4a? Well, negative 4a, if you think about it as negative 4a over 1, I'm not changing anything there, right? Divide by 1 and nothing changes. I'm just writing it so you can see it as a fraction. Because now if I quote-unquote flip it, this is what I get. I just flip the 1 so it's on top, the negative 4a so it's on bottom. If I multiply these two, I get 1. Why? Well, negative 4a times 1, you multiply right across. Negative 4a. 1 times negative 4a is equal. So we have something over itself. Anything divided by itself is 1. So that shows you the multiplicative inverse. And that goes back to the idea of the reciprocal. Thanks.